Let's talk about the most dangerously reassuring phrase in tech today. We moved to the cloud. People say it like it's a magic security blanket, right? Like you just boxed up your servers, shipped them to a fortress in the sky, and instantly solved all your infrastructure problems. But honestly, that phrase masks a massive misunderstanding of what the cloud actually is. So let's break down why that mindset is so risky. Because here is the reality check. The cloud isn't a physical place. There's no heavily guarded compound you can point to and say, yep, that's the cloud. It is just a way of delivering computing as a service over the internet. And because it's a service, that delivery model fundamentally flips who is responsible for what. You're no longer buying a permanent place, you are signing a rental contract. Think of the three main delivery models like real estate. First, you've got infrastructure as a service, or IaaS. This is basically renting a vacant lot with utilities. The provider hands you the land, but you are building the house yourself, and the operating system is entirely your responsibility. Then there's platform as a service, PaaS. Think of this like leasing a furnished apartment. The walls, the plumbing, the maintenance, that's all handled. You just bring your own apps and data. Finally, software as a service, SaaS. This is a hotel room. The building, the furniture, the cleaning crew, it's the whole shebang managed by someone else. You just show up with your suitcase. Nailing down which delivery model you're using is the absolute non-negotiable first step in every single security conversation. Why? Because the big shift here isn't where the computers sit, it's what you are actually buying. Each of those real estate models completely changes who turns the key at every layer of the tech stack. It dictates who builds the walls, who checks the locks, and at the end of the day, who takes the blame if something gets stolen. And that brings us to the shared responsibility model. Since the cloud is a rental agreement, security is always a split deal between you and the provider. Now, the provider is always going to own the physical data centers. They handle the badge readers at the door, the fire suppression systems, the actual racks of servers. You'll literally never set foot in those buildings. But the digital controls, that's where the split happens. If you're in that vacant lot, you are managing almost everything. If you're in the hotel room, you manage very little. But listen, there are two things that never, ever transfer to the provider, no matter if you're standing in a vacant lot or lounging in a luxury hotel room. They are always yours. Your data, and your identities. Sure, the provider will protect their own systems from going down, but if someone on your team accidentally deletes a crucial file, or if ransomware locks up your workspace, or if you just hand an account to the wrong person, that is entirely on you. Real data recovery and identity management, that's your job 100%. So how do you actually know the provider is holding up their end of the deal? You obviously can't just walk in and audit their physical servers, so we rely on certifications, things like SOC 2 or ISO 27001. But here's a massive trap a lot of teams fall into. Just grabbing those certificates and checking a box. You really have to dig into the fine print. What is the actual scope of that certification? Who are their sub-processors? Like, who are the providers for your provider? And seriously, look at the exceptions and the carve-outs. The pages where the auditor lists all the tests that actually failed, those are almost always the most informative pages in the entire report. Beyond the audit, the contract itself dictates your actual reality. For instance, where does your data physically live? And if there's a breach, what is the exact notification window? Are they telling you in 48 hours? Or does the contract just vaguely say without undue delay? And what about those service level agreements? A 99.9% SLA usually just means you get a tiny financial credit on your next bill if they fail. It absolutely does not magically guarantee your systems will stay online. And finally, reversibility. If you decide you want to pack up and leave, how exactly do you get your data back? Now, let's pivot to a massive architectural shift. Back in the day with a traditional office setup, your perimeter was physical. You had actual walls, locked doors, physical network firewalls. But in the cloud, your services are spread out across multiple providers, and they are explicitly designed to be accessible from the internet. That physical boundary, it has entirely dissolved. The only meaningful perimeter you have left is identity. This means we lean incredibly heavily on IAM, or Identity and Access Management. Think of IAM as the ultimate bouncer for your cloud environment. On every single digital request, every single API call, it stops and asks, who is this and what exactly are they allowed to do? The level of permission here is ridiculously granular. And the smartest way to handle this isn't by handing out permanent passwords to users. It's by granting temporary roles that humans or machines can just put on for the exact amount of time they need to do a specific job and then take off again. Of course, if you're juggling dozens of different cloud apps, figuring out who has access to what quickly turns into an absolute nightmare. That's exactly where SSO and SIM come to the rescue. Single sign-on means your users authenticate just once in a central place, and that trusted identity follows them everywhere. SIM is the engine running behind the scenes that automates the whole process, giving people access the second they're hired and, crucially, revoking it from every single app the millisecond they leave the company. Put them together and they are the ultimate cure for SaaS sprawl. But there's a modern attack vector that bypasses those traditional logins entirely, using OAuth and consent phishing. You know when you click a button that says something like, "Allow this app to access your calendar," you just handed over a digital token. And the scary part is, that token often keeps working, even if you change your password or enforce multi-factor authentication. Attackers absolutely know this. They trick users into authorizing a malicious third-party app, which grants them a shiny new token to access your data without ever needing to steal a password. Which perfectly tees up what is probably the single most useful concept to take away from this explainer. In the cloud, most incidents are not exploits. They are settings. That classic movie image of a hacker furiously typing green code to smash through a firewall? Mostly fiction here. In the cloud, the door wasn't broken down, it was just left wide open by mistake. Because identity is what handles access, the way those accesses are configured literally becomes your primary attack surface. Let's look at some concrete examples of how this plays out. In our vacant lot IaaS model, the absolute classic failure is an open storage bucket. Someone accidentally flips a simple checkbox to public, and boom, suddenly millions of highly sensitive files are completely readable by anyone on the internet who has a web browser. Or, in our furnished apartment PaaS model, it's usually a managed database that accidentally gets left exposed to the internet. When that happens, automated brute force scanners will find it within hours. There's zero hacking required. They're just finding what you left out on the front lawn. So, how do we actually harden this attack surface? First off, we never ever hard-code passwords or API keys. We lock those up in dedicated secrets management vaults. Second, we have to accept that configurations drift over time. A quick temporary fix somebody made last year might still be sitting there today, completely exposing your system. That's why we use posture management tools to continuously scan for misconfigurations. And third, we enforce strictly non-negotiable multi-factor authentication on absolutely every administrative path. No exceptions. And the reason we are so incredibly strict about administrative access is because of something called the control plane. The control plane is the central dashboard, or the command line, that pilots your entire cloud infrastructure. Back in the old days, if an attacker wanted to compromise 10 servers, they had to painstakingly hack into 10 individual servers. Today, an attacker with just one highly privileged API key on the control plane can take a snapshot of your entire database and silently copy it over to their own account. They can steal everything without ever hacking a single running server. Because one single configuration mistake or one stolen key can do that much catastrophic damage, we have to talk about controlling the blast radius. The blast radius is basically asking, when something inevitably breaks or gets compromised, how far does the damage spread? In the cloud, everything is interconnected by APIs right out of the box. So one single mistake absolutely dictates your overall blast radius. Let's walk through the actual anatomy of a typical cloud incident. It rarely looks like a Hollywood blockbuster. Step 1. An overprivileged role exists somewhere in the system. Step 2. A workload using that specific role gets compromised through some routine, boring vulnerability. Step 3. The attacker uses those perfectly valid permissions to just look around and see what else they can reach. Step 4. They extract data using totally legitimate API calls. And Step 5. They exfiltrate the data. Notice anything? Almost every single step involves the system working exactly as it was designed to work. The permissions were just sitting in the wrong hands. To stop this, we have to deliberately and proactively shrink that radius. We do this by physically separating environments into entirely different accounts, so a breach in your development sandbox can't mathematically touch your production data. We strictly enforce narrowly scoped roles, giving identities exactly what they need to do their job and absolutely nothing more. We use customer-controlled encryption, so even if data is copied, it's just cryptographic garbage without the keys. And we meticulously log control plane activity to catch weird behavior, like a brand new admin role suddenly being created at 3 in the morning. Ultimately, your entire cloud security posture boils down to answering one really uncomfortable question. When something falls, what falls with it? I want you to take any identity in your cloud right now. Look at what it is technically capable of doing, and then compare that to what it actually needs to do to perform its daily job. That gap between can do and needs to do, that is your completely avoidable blast radius. Closing that gap is the ultimate defense. So think about it. What is the blast radius of your most powerful cloud identity today?